Let's start with a pretty interesting example here where we take the limit of sine of 1 over x as x approaches 0. So with this, given the function, you could even try to plug in x equals 0, but it's going to end up undefined because we can't plug in 0 into the denominator. So that's where we go to a table of values. And the idea with the table of values is that I want to see what's happening with our function as we get closer and closer to 0 from the left and right side. So what I might do with the table is like look at negative 0.1, negative 0.01. So we want some values so that we can see what's happening as we approach from the left and from the right hand side. And we like to have multiple values so that we can see this approach. And we want to see what it's kind of going towards as we look at these. So from here, let's head over to Desmos to look at a table of values and look at what this function even looks like. So this is sine of 1 over x. It's a really interesting function, and if you get dizzy looking at the computer, maybe look away because this gets pretty trippy as we start zooming in. What you can see is I could just do this forever. It's infinite. And if I'm trying to look at x equals 0, it's just kind of a mess. So let's go to our table and see what these values do. And if you see the scatter plot, those dots are all over the place. It's positive, it's negative, and we see that in the table as well. So let's say I'm approaching from this right-hand side, I see a positive 0.9, then a negative 0.54, then a negative 0.5, then a positive 0.8, then a negative 0.3. And then I jump over to a positive 0.3. So it's like, it looks like they're getting smaller and getting closer to 0. However, it's all over the place. So with that, this is a case where the limit does not exist because we can't see a clear value that it's approaching because it's all over the place. It looks like it might be going to 0, but it's hard to see an exact value where they're matching up. Like at this point, we're positive versus negative, and they're pretty far away from 0 at this point, so we couldn't do that. So with this, because it's just all over the place, we would say the limit does not exist here because it's not clearly matching up at any point. Okay, from there, let's talk about one-sided limits. So if we can make the values of f of x arbitrarily close to a number L, so we're getting closer and closer to some output of L by taking x to be sufficiently close to a number A for values of x less than A. So this first one, we're just looking at values smaller. Then we write, and our notation changes ever so slightly. What we do is we have kind of the superscript, it's even like it's an exponent, that's a negative symbol. So how we read this is the limit of f of x as x approaches A from the left is equal to L. So with these, we're only looking at what are the values approaching from the left-hand side. Then down here, our notation changes to have a plus sign. What that means is that we're going to take the limit of f of x as x approaches A from the right, and that's going to equal some limit L. So let's take a look at an example with this. So this notation here, I'm looking at the limit of our function that's graphed below as x approaches 2 from the left-hand side. So what I'm going to do is look at where is x equal to 2. Ooh, and there's no scale here. Let's say this is 2. And let's use units of 2 there as well. Okay, so I have this scale of 2. So if I'm approaching 2 from the left-hand side, I'm only focusing on these x values that are smaller. So like in the previous video, I talked about like walking to meet up with your friend. Well, now don't have any friends, you're just walking alone. So it's just on your own. What are you approaching? So on our function, we're walking along our function on this left-hand side, and we want to see what are we getting closer and closer to as we get close to that x value of 2. And what we want is that y-coordinate, which in this case would be an output of 3. So as x approaches 2 from the left, so now we have a direction, f of x approaches 3, and that's going to be our limit. So as x approaches 2 from the left, our function is getting closer and closer to 3. Then our next one would be what's happening as x approaches 2 from the right. So now we're coming from this side. So our function, if we're walking along our function from the right-hand side and we want to know what is our function approaching, well, we're approaching the x-axis, which would be a value of 0. So as x approaches 2 from the right, our function is approaching a y value of 0. So our limit as x approaches 2 from the right would be 0. Now let's go back to our previous notation. So this would mean from the left and right. So this is where we have our buddy walking towards us. So we have our friend from the left and right. So there's 2 of us. And in this case, what we could see, even just looking at our solutions, so the limit from the left is 3, the limit from the right was 0, we're not matching up. So because they don't match up, that's where we would have the limit does not exist. It has to match up in order for it to exist. And that's a rule that we'll have that I'll write over here. So the limit exists. Sorry, let's say the two-sided limit. Limit exists only if the one-sided limits are the same. So, for example, if we go back to the picture from the previous video, here, so let's go to x equals 1. What I could have done is I could evaluate the left-sided limit, and the left-sided limit would have been that output of 2. I could have evaluated the right-sided limit. It would also be a value of 2. And then when I do the two-sided limit, which is what we did in that last video, it is also 2. So when they match up, it all aligns. But what we saw with this last case is that left-sided limit, let me zoom out here, that left-sided limit was like a 3.75. The right-sided limit was a 1. So because they don't match up, that's where the limit does not exist. So we can evaluate one-sided limits, two-sided limits. Just pay attention to the notation and the subscript where x approaches a number, and just be careful of if you see a minus or plus, that'll tell you to only look at one side of the graph or that one side of x rather than both.